Hello friends, in this video we will see why Q8 sitting inside S8 but not before Q8 sitting inside S8. This is because of Kaila's theorem but not before any SK where K is less than or equal to 7. Okay, this uses the heavily grouped action property. At least the proof I know uses the group action property. I will prove like that. Okay, so I wanted to prove Q8 to SK when K less than or equal to 7, any homomorphism, let me say F, any homomorphism, any group homomorphism, actually not injective. If I prove that, then I am done. Okay, the first fact, recall Q8 the subgroup lattices, that is plus 1. If you don't see, I have uploaded a video about the group Q8 introduction. You see that, then come here, you can understand. There I explained everything. The group generated by I, group generated by J, group generated by K. This is a subgroup lattices. They are exactly one order 2. One order 2 subgroup. Okay. Now I wanted to prove this fact. Any homomorphism actually not injective. In the group action, it's nice, it's easy that G acting on S is same as giving homomorphism to Sx in vice versa category. So Q8 giving homomorphism to Sk, let's say K less than or equal to 7, is same as giving Q8 acting on 1 2 dot 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 K when K less than or equal to 7. Okay, both are same because the here K, the underlying set means this one. Okay, giving a group action is same as giving this homomorphism. Okay, there I defined what is kernel of action, that is intersection of all stabilizer, and also proved in my group like actions videos that kernel of this thing is kernel of action is kernel of the homomorphism, kernel of the homomorphism. Okay, so what I am going to prove, this is greater than 1 always. This is what I wanted to prove. Okay, so there is a RV stabilizer theorem that we have stabilizer of X into orbit of X equal to the group order. Here we have 8. Okay, orbit of X into stabilizer of X. But remember that the orbit of X must be less than or equal to 7 because the orbit of X is subset of 1 2 up to K less than or equal to 7. So the orbit of X is less than or equal to 7. Hence, that implies the stabilizer of X must be greater than or equal to 2. This is the fact. Now come back, look at this thing. There is only one subgroup of order 2. That means each stabilizer contains plus or minus 1. That means plus or minus 1 is inside each stabilizer. Because of this is at least order 2, right? It is at least order 2. We have the subgroup lattice plus or minus 1. Okay, 1 plus or minus 1, I generated by I generated by J generated by K. Okay, so from here we can conclude that everything, because there is only one, so this is at least order 2, this is going to happen. So that means the intersection of X belongs to X, that means that our set 1 up to K stabilizer of X contains plus or minus 1, right? So that implies kernel of the action contains plus or minus 1. Certainly the order of kernel is greater than or equal to 2. So that implies this is same as the kernel of the homomorphism. So that implies no Q8 any homomorphism when k is less than or equal to 7 can't be a injective map because kernel is always greater than 2. Hence Q8 is not possible. So from here we can understand that Q8 goes inside S8 because of Cayley's theorem, but not any SK. Hence there is a limitation on this n. Okay, so even though it is a small group order 8, even though it's a small group of order 8, still we have to throw into 8 factorial, not before anything. Okay, so this is a very important fact. Okay, thank you. Share as much as possible to the people who need it.